This lesson is going to investigate some practical applications of trig for machine-related problems. In particular, we're going to look at sine bars, we're going to look at tapers and bevels, and we're also going to look at V-notches. Now, I only am going to give you a couple examples of each, but it should be enough to get you working at some practice because they're really quite simple questions. So the first example we're going to look at uses a sine bar or a sine plate. Okay, so here we have a 5-inch long bar. It has an included angle. It's set up so that it has an angle of 24 degrees, 21 minutes. And we want to figure out, in order to achieve that, what height of gauge blocks are we going to have to include? So to solve this question, the first thing I recommend doing is labeling the triangle. So we know that the bar makes our hypotenuse because that is opposite the right angle. Opposite of this angle of 24 degrees, we have the opposite side. That's also happens to be what we're looking for, our H. I'm not sure what's going on here. I must be using too much pressure. We don't know the adjacent side, and it really doesn't matter for the case of this question, so we don't even really need to label it. Now, which ratio are we going to use? If we look at the expression SOHCAHTOA, we can see that sine uses opposite and hypotenuse. It also happens to be where sine bars get their name from. If you're using a sine bar to do calculations, you will always use the sine function. So in order to find the height of gauge block, the gauge blocks here are height x, we're going to put the information from our triangle in. So the sine of our angle is equal to opposite over hypotenuse. Filling in the information, the sine of the angle, 24 degrees, 21 minutes, is equal to opposite is x divided by 5 inches. Now we can rearrange it. In order to solve this, if you wish, you could put this in your calculator right at the beginning. You can do that if you would like. I'm going to leave that up to you. If you do put that in your calculator, keep 4 or 5 decimals. That's important. If you're not, the book also gives you the calculator keystroke. So you can look up figure 63, 1 in the machining textbook. So x is going to be equal to get rid of x on the bottom, we multiply it to the other side. 5 times sine of 24 degrees, 21 minutes. Now, just for simplicity's sake, I did calculate the decimal out. So if you're having trouble putting it in one stretch, just do the sine of 24 degrees, 21 minutes. So 24 DMS button, degree minute second button, 21 degree minute second button, and then press sine. It will give you this ratio: 0.4, 1, 2, 3. Now I've kept it 4 decimal places. You could keep a little more if you want to be even more precise. Multiplying that by 5, we find x is equal to 2.062 inches. So that's the height we would have to achieve with our gauge blocks. Now, of course, you're going to have to think this question didn't tell us what precision to use, and 5 inches isn't extremely precise, but you're going to have to decide how precise you need to be. Now, because it went down to not just degrees, it also gave us minutes, I use that as my clue that I should probably keep at least 3 decimal places, or at least to the nearest thousandth of an inch. But this is one of those situations where it may be a judgment call based on the application. Our second example is the same kind of question, but in this case, we have a block height, we have a bar length, and we want to find out what is angle x. So we're looking for the angle here. So again, label your sides. It's just a good habit, even though we know, because we're dealing with a sine bar, it's going to use sine. So the sine of our angle is going to be equal to opposite over hypotenuse. So the sine, I'm going to call this angle x, is equal to the opposite side now is 3.0625 inches divided by 10. So we're going to get sine x is equal to 0.30625. Now, this is a situation we're looking for an angle, so we're going to use that shift sign. So x is going to be equal to, the shift sign gives you this particular function, inverse sign of the decimal. So you'll put in your particular calculator, you should be used to it by now. You'll put your decimal in first, and then you're going to do shift sign and equals. And you should get that the x angle is equal to, let me flip my page here where I have my solutions written out. The angle x is 17.833 degrees. And if we wanted to get degrees, minutes, and seconds, just press your degree, minute, second button, and you will find you get 17 degrees 50 minutes. So that gives us two different ways in order to put it in. Depending on what equipment you're using, you may use one or you may use the other. It's a nice, easy question. So a sign bar or sign plate is an easy one because it tells you what ratio to use. You just have to be able to decide which numbers go in the right places. The bar length is always the hypotenuse, so that may help you a little bit. The next example we're going to look at deals with a bevel or a taper. So here we want to solve for the taper angle of this part, and it tells us all of our measurements are in inches. So this would be like a kind of like a cone shape. We have a diameter of 1.8 inches on the far end. And then down over here, we have a 700th thou diameter down on this end, and it tapers out to that. Now, when machining, when they give a taper angle, the taper angle would be the entire angle, as if this went right down to a point. I'm not going to draw, well, I guess I could draw a point in and erase it, okay? So when they talk a taper angle, that would be our taper angle. But oftentimes a part is machined so that both ends are flat, so you don't actually see that fine point. So the way that they show that to us is they say, well, if we could section this off and just taper this as if there was nothing here. So start at the top edge of it and draw a horizontal line, so a line that's parallel to the center of the part. It will give us half of our taper angle because we have an equal taper on the other side. So we're going to be looking, if we want the taper angle, we're going to have to find what is this angle, and then we double it because it would be twice as wide if we went out to a point. Hopefully that makes a little bit of sense to you. If it doesn't, pop me a quick Zoom chat. I don't mind talking to you. You can always book the link using Sam. So let's do our calculations. So we can see we have a right triangle because these two lines are parallel. Here's our right angle. And I'm actually going to re-sketch our taper just because I think it helps us finding our lengths a little bit. So if we look at the numbers in the diagram, there's quite a few numbers, and we're going to simplify it, drawing it out this way and make it easier. So down here we have 10.5 inches. So that's along the base, and that's going to stay. So we got our 10.5 inches, and we want to know, we're looking for this angle. So that's what we want to find. And we need to figure out, we either need to know the height or the hypotenuse in order to solve this. Now, there's nothing to give us the hypotenuse, but we can use this information to get our height. So if I take this and I divide it by 2, I know that this height just there is 0.900 inches. And here, if I just do half of that, I have 0.35. So if I want to find out what's just this little height, the part in my triangle, I'm going to do 0.9 minus 0.35. And we are left with a height that is equal to 0.550 inches. So that's this particular height. Now, which ratio are we going to use? Well, here's our right angle. This is the subject angle. So here's my adjacent side. This is my opposite side. So check SOHCAHTOA. SOHCAHTOA. Tan uses opposite and adjacent. So we're going to use the tan ratio for tapers. So the tan of the angle is equal to opposite side first. It goes on the top, so the opposite side is 0.550 divided by the adjacent of 10.50. Putting this into your calculator, you will get tan of the angle is equal to 0.05238. Looking for an angle, so we use shift tan. All right, this is supposed to be a 0. So we have that. And in our terms of what our calculator gives us, our calculator tells us that angle is equal to 2.998 degrees. Now, the taper angle is double that. So it's going to be 2 times 2.998 degrees, which gives us 5.9969, which I'm going to say is about 6 degrees. I don't know that even if we round that off to 2 decimal places, we're going to really go to about 6 degrees. All right, so taper angle, you find your angle and then you double it. Now, if we were going backwards and they tell you what the taper angle is, then we would have to divide our angle by 2. So that's something just to kind of watch for in a word problem, is you might get another way to look at the question. Here's another question that has a bevel. So you have a part and it's got, well, we actually have 2 bevels here, but we're only going to really use this large bevel. So we have a large bevel. We know the bevel angle is 32.5 degrees. And we want to know, okay, if that's the case, what's the diameter X over here? Now, in this particular image, we have all of our measurements in millimeters instead of inches. You'll find in this book, if it's 2 decimal places, it's usually millimeters. If it's 3 decimal places or 4 decimal places, it's going to usually be inches. So it's just one of those, if I miss giving you a unit, that's usually what it happens to be. So in order to solve this particular question, first thing we're going to do is we're going to find a right angle, and I'm going to strongly recommend you sketch it out and think about what our pictures. So I think it's easy to see that there's our triangle. Do you agree? Okay, so, well, my artwork is definitely lacking. We'll try again. There's got to be some tools to help with straight lines on these, but anyway. Okay, so we have our right triangle, and now we need to fill in some information. So we know the angle. So if there's our triangle, the taper, the bevel angle over here is the same as the angle in our triangle. So this angle is 32.5 degrees. Okay. Now we need some sides. So what sides can we find? So I'm looking for X. In order to find X, I'm going to have to find this height and subtract it from what we have on the far end. Okay. So I'm going to be looking for this. So I'm going to call this, well, it's opposite. So I'm going to call it opposite, just for easy words. The base here, I have some information I can use to calculate this. So to find this side, this is my adjacent. To find that side, we're going to use this 21.8 and the 7.5. So I could do 21.8 minus 7.5, and that gives us a length of 14.3. You can keep the zeros on the end if you want, but sometimes it's easier when you're in the middle of your calculation to simplify a little bit. Now, we don't have the hypotenuse. We don't really care about the hypotenuse. What ratio should we use? The only ratio that doesn't use hypotenuse is tan. So the tan of our angle is opposite over adjacent. So just substitute the information in. Tan of 32.5 degrees is equal to, opposite is what we're looking for, divided by the adjacent of 14.3. The opposite side is 14.3 times the tan of 32.5, which gives you, if you put that into your calculator, you're going to get the opposite side is 9.11 millimeters. Now that's not the end of our question. We just simply found out this measurement. So now we have to find out, well, what is diameter X? So X is equal to the full diameter of the other end, so 26.25 minus, we're going to actually subtract the 9.11 twice because you have 9.11 here, and you also have it over here. So we're going to minus 2 times 9.11, and I'm going to write it like this simply because it's a good order of operations question. So 26.25 minus 2 times 9.11 leaves us with a diameter on that end of 8.03 millimeters. Okay, so it's not an overly complicated question. It looks more complicated than it is. The key is simplify to get yourself a simple triangle. Once you have a simple triangle, the question becomes much easier. And I find sometimes it really helpful just to pull the information out like this. One final question for today is going to be a V block. I have actually skipped a couple examples in order to get this one. It's the simplest of what we have left to cover. So I figured it would be a good one to pop into this lesson just to kind of ease you in. And next day we'll get you a couple. They're going to be questions that are like V block questions, but they kind of maybe stretch the way that you think about it. So if we want to solve for the depth, so we want to find out how deep is this V. So if I want to figure out how deep is the V, I'm going to need two pieces of information. I either need an angle and a side, or I'd need two sides. So in this case, we have an angle and we have a side, but this large V does not make a right angle. So we always split them down the middle. So whenever we do a V block question, we are going to use all of our dimensions in halves. Okay, so along the top, we need to take this and we're going to divide it by 2. And you will get 1.928 inches. The angle has to be split in 2, and you can actually keep it in degree, minute, second if you want. So 62 degree, minute, second button, 46 degree, minute, second button, divide by 2, and it will work to actually split the angle for you. So 31 degrees, 23 minutes. And X is our depth. So it's actually a pretty simple question. I don't know if you've noticed, but we've been using tan a lot. And this is another example that uses tan. So we have opposite and we have adjacent. So the tan of our angle is equal to opposite divided by the adjacent. We're looking for adjacent this time, which is going to make our rearranging a little different. So the tan of 31 degrees, 23 minutes is equal to 1.928 inches divided by X. Now this is the one where they trade places. What we're looking for is on the bottom. So we're going to have X equals 1.928 divided by the tan of 31 degrees, 23 minutes. You may want to put this in your calculator in 2 steps. You don't have to. You'll find if you look up 63-6 in your book, if you have your book at home, it will go through the keystrokes with you. That's one advantage to that book. But think about how you've been calculating your questions so far. You're not looking for an angle, so you don't have to use shift. You're just going to use the tan button. So if you have what I call the backwards calculator, the one where you put the degree in first, you'll put 31 degree minute second button, 23 degree minute second button, then press tan. That will calculate the bottom for you. And you may want to write that out separately. So if you were to do that, this is one where I find sometimes that's helpful. So X is 1.928 divided by, I guess I didn't write it out separately. So I'm going to just take 30 seconds to calculate it, if I can find where I set my calculator. Tan of 31 and 23. You would get 0.6100, and that gives you an X length of 3.156 inches. Okay, so pretty easy to calculate, not too complicated. The biggest piece of advice I can give you for this particular group is simplify, simplify, simplify. Get it down to just a simple triangle. I love solving these because I can see it. Some of you will have a harder time with them. If you don't, that's great, but some people will have a harder time with these. That's not unusual. The biggest key is simplify. So look at how can I make this diagram more simple, more easy. So that concludes this lesson.